Hi, my name is Mike Ferguson of Intelligent Business Strategies. I want to talk to you about data products. I frequently get asked two questions by a lot of my clients, and that is, what's a data product? That's the first question. And the second question is, what's the best data architecture to use to build data products? Given that data products were initially kind of popularized by the emergence of data mesh back in 2019, um, and have since kind of taken on a life of their own. So let's look at the first one. What's a data product? For me, I make a very clear distinction between data products and analytical products. A data product is a data set, which is typically representing a data entity within your enterprise. An analytical product, for example, within an organization, could be a BI report, it could be a dashboard, it could be a machine learning model, it could be an AI agent. All of those things, in my opinion, are analytical products. And we're seeing lots of those, but they are typically produced by using data from data products. And within data products, you could argue there are foundational data products. These are things that every business has, customers, products, orders, shipments, returns. If you're in insurance, it could be claims. All key master data entities and transaction types are great examples of entities which data product, where you should build a data product for each one of those. But they're also, if you like building blocks, that I should be able to combine these things in order to be able to support different analytical workloads. And so that opens up a second question I get asked a lot of, and that is, what's the best architecture to build data products if we're going to democratize data engineering, so that multiple people around the organization can go and build these things? And in that question, there's a lot of confusion because many different vendors are promoting different kinds of data architecture to do this thing. Some vendors promoting something like Kafka to go and build data products in a message-oriented middleware environment. Some vendors talking about doing it on a zoned data lake. Others talking about doing it on cloud data warehousing, or to do it with data virtualization software, or a combination of data virtualization on top of a data lake, or lake houses, or a combination of data virtualization and lake houses. So you kind of look at all of this and you go, well, which is it? And can we do this in a way that simplifies data architecture at the same time as democratizing data engineering? And I think one of the things, at least from my perspective, that stands out has been the emergence of open table formats like Delta Lake, which is the Linux Foundation project these days, or Apache Iceberg, or Apache Hoodie. And I think today every data warehouse vendor is no longer just a data warehouse vendor. They're a lake house vendor because they all support open table formats. In particular, it seems to be that Apache Iceberg has become the most popular. But Delta Lake, I guess, also widely supported by several vendors. The beauty of that, though, is that I could engineer data and create data products that could be stored in open table formats. And it doesn't have to be on a central data lakehouse, for example, to make that happen. You could do it on, domain-oriented lakehouses, as long as there's a way to have a common place to register these data products and be able to govern the sharing of them and create data contracts and monitor their usage. But the key point is that if I could build these data products once as, if you like, composable data building blocks, I could combine them to use by multiple analytical engines to supporting different multiple analytical workloads. For example, data warehouse query engine, accessing open tables to combine them to create a data mart and support BI users. Similarly, data scientists using Spark could also access the same shared data products and be able to use that data as input to creating features for a machine learning model, for example. Also, now that SQL standard supports graph analytics, I could support graph analytics on top of data products that are stored in open table format. And I can even update them in near real time and stream live data into those open tables from something like Apache Flink whilst I'm doing streaming analytics at the same time. So open tables hold a really exciting future. And for me, certainly that makes Lakehouse probably a standout data architecture, whether it's one or multiple lakehouses around the enterprise, as long as we have a common approach to govern the publishing and sharing of these, and a common approach to create data contracts and governing the usage of this around the enterprise. So if you've got any opinions on this, I'd love to hear it, whether they're things that you succeeded with, things that you failed with. And if you differ in opinion, that's fine also. So please let me know. And thanks for listening.